Assalamu alaikum and good morning to one and all. Today in this video we are going to learn something from atoms and molecule, that is unit number 7 in chemistry. Today's topic is calculating the percentage of an element based on a compound. So the mass percentage of an element has to be calculated from a compound is our topic today. How to calculate it? First let me give an example. See, CH4 is given here. CH4 is nothing but methane. To form a methane, we need 1 carbon and 4 hydrogen atoms to form methane. Now my question is, how many percentage of carbon is here and how much of hydrogen is there to combine and give a compound of methane molecule. This is methane is a compound. So how much percentage of carbon is there and how much percentage of hydrogen is existing in the methane has to be calculated. How we can calculate it? We can done it with the help of a formula. So mass percentage of an element can be calculated with a formula. First we have to found the molar mass of a compound. Molar mass of a compound, then initially we should know what is the mass of that element in a compound. It means total mass of the element in that compound, then divided by molar mass of a compound into 100. What is this molar mass? It has one more name, that is called as gram molecular mass, or we can call it as molar mass. How we can calculate this thing? It is very important. We can be calculate from algebraic sum of gram atomic mass of elements. It means that we should know the gram atomic mass of individual element, and adding those gram atomic mass, then we can calculate the gram molecular mass or molar mass. After knowing that, we can calculate these percentage of an element with the help of this formula. See, let me show how to calculate gram molecular mass or molar mass. First, what is given here? Let us consider as methane. So methane is nothing but CH4. How much of carbon is here? 1 carbon and 4 hydrogen atoms is there. So solution is, we have to calculate first molar mass. So molar mass of compound, that is molar mass of methane, can be calculated as 1 into carbon plus 4 into hydrogen. So what is the value of carbon? Here we need gram atomic mass of carbon and hydrogen. Let me give here. Gram atomic of hydrogen is, atomic mass of hydrogen is 1 gram. Gram atomic mass of lithium is 7 gram. Then gram atomic mass of nitrogen is 14 gram. Gram atomic mass of calcium is 40 gram. For carbon it is 12 gram. For oxygen it is 16 gram. So for hydrogen it is 1 gram, for carbon it is 12 gram, for nitrogen it is 14 gram, for oxygen it is 16 gram. Lithium is 7 gram, then calcium is 40 gram, sulfur is 32 gram, and iron is 56 gram. So these are some of the ready-made values which has been found by the scientists. You should keep in mind by yourself, because in certain cases the question will be asked as a vague to find everything based on our memorized values or known values. In certain cases these values will be given in the question itself. So here it has not given. Now I am going to substitute here 1 into carbon. So carbon value is 12 gram plus 4 into hydrogen. Hydrogen value is 1 gram. So I am using here 1 gram. So 112 is 12 plus 14 is 4. So what is the value here? 16 gram is the molar mass of methane. What is our ultimate aim? Our ultimate aim is to calculate percentage of, that is mass percentage of, what is that? Carbon. Mass percentage of carbon. For that we should know that mass of that element. How much of mass is here? How much carbon is here? So 1 carbon is here. What is the molar mass? It is 16 gram, then into 100. This is the formula. So 1 into carbon value is 12 divided by 16 into 100. So I can say like here 112 is 12 divided by 16 into 100. So I am dividing it in 4, 3 4s are 12, 4 4s are 16. 1 4 is 4, then 25 4s are 100. So 25 into 3 is 75 percentage of carbon is existing in a methane molecule. You can check it, only 25 percentage of carbon alone will be there in methane molecule, in methane compound. So this is the method how to calculate. Here see, in second problem it is existing in page number 104, and question number 2 and 3 I have written here. See here, calculate the percentage of each element in calcium carbonate. See, each element means we have to calculate for all the element which is present in a compound. See what is given as question, and calcium carbonate. What is the formula for calcium carbonate? Yes, CaCO3 is calcium carbonate. Here values already atomic mass, that is gram atomic, has been given by the question itself. Now see here how to calculate calcium carbonate's molar mass. First one is molar mass of calcium carbonate. See, we have to know that 1 into calcium plus 1 into carbon, but oxygen is 3. Am I right? So 1 into calcium value is already has given 40 gram. Then carbon value is already has given 12 gram. Then oxygen value is already has given 16 gram. So 140 is 40, 112 is 12, then 3 into 16 is 48. And calculating 48, 50, 60 plus 100 gram is the molar mass of calcium carbonate. What is our ultimate aim? Our ultimate aim is mass percentage of each element. Each element means first one we have to take mass percentage of calcium, then carbon, then oxygen. How to calculate it? Mass of that element. That is, mass of that element means carbon or calcium. Mass of calcium divided by molar mass into 100, because we have to calculating percentage, so we are multiplying it by 100. See here, how many calcium is here in the compound? 1 into calcium, then molar mass is 100 gram into 100. So calcium value is already we know 40 divided by 100 into 100. So this 100 and this 100 get cancelled. So 1 into 40 is 40 percentage. So mass percentage of calcium is 40% in calcium carbonate. Hope you understand. So one more I am explaining here. You can take oxygen. So mass percentage of oxygen in calcium carbonate. So how we can calculate mass of oxygen in calcium carbonate? How much of calcium is in calcium carbonate? 3 oxygen is this, CaCO3. So 3 oxygen is there, divided by molar mass is 100 into 100. So 3 into oxygen value is 16 divided by 100. You can make it as a bracket also. So into 100. So 3 16s are 48. So 100 get cancelled. So answer is 48 percentage. So mass percentage of oxygen in calcium carbonate is 48%. So remaining is nothing but we can get as a carbon is remaining. So dear students, see here, third question, calculate the mass percentage of oxygen in aluminum sulfate, that is Al2SO4 thrice. Here the atomic mass of aluminum is 27 gram, oxygen is 16 gram and sulfur is 32 gram. He has given it. So we have to calculate the mass percentage of oxygen. Before that we have to calculate molar mass of Al2SO4 thrice. So this is the solution. So how much of aluminum is here? 2 into aluminum plus sulfur is 1. So 100 is yes. Then oxygen is 4. So oxygen is 4. Everything is multiplied commonly by 3. So this step is very important. So SS1 oxygen is 4. Then everything is multiplied whole by bracket. So I am multiplying here. Come here, let us learn. 2 into aluminum is 27 gram as he given, plus sulfur value is 32 into 1, plus oxygen value is 16 into 4. Then everything is multiplied by 3. So 227s are 54 grams. Then here 132 is 32 plus 16 fours are 16 32, then 32 plus 32 64. Then everything is multiplied by 3. See here 54 plus, and adding this 2 plus 4 it gives 6, 6 plus 3 9, 96 into 3. So 54 plus 6 3s are 18, 1 remaining, 9 3s are 27 plus 1 28. So 288 plus 54 we will get here as 8 plus 4 12, 1 is remaining, then 5 plus 8 13, 13 plus 1 is 14, then 2 plus 1 is 3. So 342 gram is the molar mass of Al2SO4 thrice. If find difficulty, you can write individually like here. See, 8 plus 4 is 12, 8 plus 5 13, plus 1 14. Now so 342 grams is the molar mass of aluminum sulfate. Our ultimate aim is mass percentage of oxygen in Al2SO4 thrice. For that we know, so mass of oxygen, that is total mass of oxygen in Al2SO4 thrice divided by molar mass into 100. See here, how much of oxygen is here? We can come to the question here. So 4 is here, 4 into oxygen, and already multiplied by 3. So 12 oxygen atoms divided by molar mass is 342 into 100. So 12 into oxygen value is 16 divided by 342 into 100. Now we have to multiply these things. So 16 into 12. 2 6 are 12. 2 1 is 2 plus 1 is 3. 1 6 1 1. So 291. So 192 divided by 342 into 100. So I can divide it by 3. 1 3 is 3. 1 3 is 3. Remaining 1. So it becomes 12. 4 3s are 12. Here 6 3s are 18. 1 is remaining. So it will become 12. So 12 4 3s are 12. In second table I can write 5 2s are 10. 1 is remaining, 14 means 7 2s are 14. The same second table, 3 2s are 6, 2 2s are 4. So 32 into 100, it gives 3200 divided by 57. A value of 56.1 percentage is the mass percentage of oxygen. So hope you understood this problem too. You can try by yourself as an assignment. Calculate the mass percentage of hydrogen and oxygen in water, that is H2O. Then calculate the mass percentage of nitrogen in nitric acid. Nitric acid is nothing but HNO3. So you know the value of hydrogen and nitrogen and oxygen. You can calculate by yourself. And thank you for watching.